So the next topic for Unit 3 is polynomial extrema with domain restrictions. In the first lesson for this unit, we talked about relative and absolute extrema, but for a domain restriction, some of the rules change a little bit. So we have this polynomial, but the domain is restricted on the left side, but it is still unrestricted on the right side. So if we think about what we talked about in the last couple topics, we see a relative maximum at x equals -2, a relative minimum at x equals 0, and then a relative maximum at x equals 3. Now, with this restricted domain, we see that the function is ending over here at x equals -4. That is going to be another relative extrema. So we'll have a relative minimum, a relative max, relative minimum, and then another relative max. Had the domain not been restricted on the left side, the function would continue to -infinity or continue approaching -infinity. But because we have this restriction, we now have another point that is the lowest point locally in this area, so we can call that another relative extrema. So the question below is saying we have local minimums at, so this is asking where they are located. It's going to be at x equals -4 and x equals 0. And then local maximums at x equals -2 and x equals +3. And then again, this is approaching -infinity as far as the outputs. So we do not have a relative extrema on that side. Now for absolute extrema, this is still going to be the absolute highest point for the graph or the absolute lowest point on the graph. So the domain restriction does not change that expectation for absolute or global extrema. So if we look at the same polynomial, we saw that at x equals 3 we had a relative maximum, and at x equals -2 we had a relative maximum. But at x equals 3, that is the absolute highest output, which has a value of 2 for this particular domain-restricted polynomial. So we have an absolute maximum at x equals 2. Well, I guess this one's asking different. The first part was just asking where it was. This one wants more detail. So we'll say the absolute maximum is 2 when x equals 3. And then the absolute minimum. So in the previous one, we saw a relative minimum at x equals -4 and another relative minimum at x equals 0. But then we also noticed that the graph continues to approach -infinity as far as the outputs. Therefore, this is not the absolute lowest y value, and neither is this one. These are both being surpassed by the end of the function over here, so that means we do not have an absolute minimum. So the absolute minimum does not exist. And that's going to be a possibility with these polynomials that are only, well, actually, it's going to happen. Our polynomial was only restricted on one side, all right, but not the other. Now, had it been restricted on both sides, then you would most definitely have an absolute maximum somewhere and an absolute minimum somewhere. But whenever one side is restricted, you will end up with one of those not existing. All right, hope this helps.